This problem's asking us to write a polynomial function, probably of least degree with maybe a leading coefficient of 1. And we're going to be given these three problems. All right, so we're going to do kind of one at a time here. Start with the most easiest one, which is when we have the roots of -5 and 7. All right, so if you think that those are the roots, or sometimes they're called the solutions, what we need to do to start this is think that this is actually x equals -5 and x equals 7. Okay, and what we need to do after that is find the factors, eventually multiply these things together to get the polynomial that created this thing. Okay, so what we're going to think is we're going to add this back over and get actually x plus 5, and then we're going to leave off the equals 0 because this is a factor now. And same thing for this one. If I subtract the 7 over, x minus 7 is the factor. And then you can just multiply those things together. That'll give us the polynomial. For example, we have x times x is x squared. X times -7 is -7x. 5 times x is a positive 5x. And lastly, 5 times -7 is -35. Our two middle terms here can combine, and so the polynomial that is the polynomial function of this is going to be x squared minus 2x minus 35. And since it's a function, it's probably safe to throw an f of x equals in front of this. And we can say f of x equals x squared minus 2x minus 35. All right, now that's nice. That's easy when you have ones that are kind of integers like this. But what if we have some imaginary numbers? We're going to do that next. All right, let's try it. The first one here, actually, let me get this erased for us. All right, that first one that has the imaginary is going to be 6 and a 4i. Now the 6 is easy, just like before. This is x equals 6, and so the factor that would create that is going to be x minus 6 if I were to subtract 6 to the other side. Okay, however, when you have an I, think about where an I comes from. The only way that you get an I in an answer is if you take the square root of a negative number. For example, if I take the square root of a -4, this is going to be 2i, and since we took the square root, it's going to be plus or minus 2i. Now, that plus or minus is really important because up here, I can't just have a positive 4i. I also need its counterpart, negative 4i. Okay, so I'm going to erase this down here. And I need to actually have x equals, I'm going to say plus or minus 4i. All right. Now, we don't want the I. I's, you can't work with that. We want this to just have x's. And so because of that, the only way to get rid of an I and get it to be a number is if we square it. And if we square an I, we get -1. So on this, I'm going to square both sides of my equal sign here, so it's still true. And this is going to give me x squared equals, and then think 4 squared, whether it's positive or negative, is going to be 16. -4 squared or positive 4 squared, and then I squared is going to be a -1. So this is really saying that now we have 16 times a -1, or x squared is going to equal a -16 if you multiply those together. That's important because now my factor that I'm going to have, if I add the 16 over, is going to be x squared plus 16. Okay, now you can go ahead and FOIL this together like we did in the last one, and that's going to be the polynomial function that created those two roots. All right, so let's go ahead and multiply this in. X times x squared is x to the third. X times 16 is 16x. -6 times x squared is -6x squared. And lastly, -6 times 16 is a -96. Just have to reorder those two. And I think my final answer here is x to the third minus 6x squared plus 16x minus 96. And again, you can throw an f of x equals in front of it, and that would be your final answer. Okay, this last one we're going to do a little bit quicker. However, it's going to take a little bit more room. So again, I need to do some erasing. All right, now just like before, we have a nice easy root. That's going to be 3. And this was from the factor x minus 3, because if I have x equals 3, subtract it over, it's going to be x minus 3 for its factor. And same thing as before, when I had the 4i, a 2i, I need to have a plus or minus 2i. And if I have that, x equals plus or minus 2i, to get rid of this I, we're just going to square both sides. And that will give us x squared equals 4. And then I squared is a -1, so it'll be a -4. So the factor is going to be x squared, add that over, plus 4. All right, same thing for the other one. I need a plus or minus I. And it's going to do the same thing. You might be able to get to a point where you can just see what it's going to be, but for the sake of this, I'll write it out again. X equals plus or minus I, square both sides. And here we're going to end up with x squared equals -1. Add the -1 over, and x squared plus 1 is the factor. Now, what I like to do when I have three terms, three factors, I should say, is I like to multiply together the two most complicated ones. And here, I think it's the ones that have both the x squareds. And if I put those together, then I'm going to get, some sort of probably trinomial or quad polynomial, okay? And then I can go ahead and take this x minus 3 and multiply it through because these will be easier to multiply afterwards as opposed to x squareds. So that said, I'm going to take just those two and put them together. We'll save this one for later, all right? And if I take x squared times x squared, that's going to be x to the 4th. X squared times 1 is x squared. And then 4 times x squared is 4x squared. And lastly, 4 times 1 is 4. Okay, so if I put together the two middles there, I think I end up with x to the 4th plus 5x squared plus 4. And then now we're going to take our x minus 3 from the beginning and multiply that through. Okay, let me do this really quick for you. All right, so I went ahead and multiplied that together, and I got this big, long polynomial, and then I just had to put it in the right order. So my exponents go 5, 4, 3, 2, 1, none. And now I know that it's correct. Again, you might want to throw in an f of x equals in front of it, so that now you actually have a polynomial function. All right, hopefully you found this video helpful about polynomial functions. If you have to go back and rewatch any of that, I know it can be a little bit tricky. So we'll see you in the next one.